Hey guys, welcome to question MM202 of the Maths Methods Fortify study guide. So in this question, we have no calculator, not allowed to use our CAS, and we know that it is worth 3 marks. So the question tells us the line 0 equals y take bx take 4 plus pi over 2 root 3 is a tangent to the curve y equals 2 sine of x on 2 plus a at the point pi on 3 c, where a, b, and c are real constants. Find the values of a, b, and c. Sweet. So guys, the first thing that I like to do with these questions is to actually rearrange our tangent equation so we can actually see what is going on, because I don't like having it in this form. I want it in y equals mx plus c form. So I'm going to rearrange this tangent to y equals bx plus 4 take pi over 2 root 3. Awesome. So that's the first thing I like to do personally. So then I can actually tell that the gradient of this tangent, because whenever we deal with tangents, we're going to need to use the gradient function to find out what the gradient is of the original at the point of the tangent. So we know that the gradient of the tangent is b, right? Because bx is like our mx section of the equation. So we know that the gradient of this function here at this point is equal to b. Right, so gradient at x equals pi on 3 is equal to b. Right, because that's the gradient of our tangent, so it has to be the gradient at the same point on the graph. So that means that the gradient function of this original graph is going to be equal to just cos of x on 2, right? So this is our gradient function, cos of x on 2, and our plus a just turns into 0. That's a constant, so it just cancels out when we find the gradient function. So at x equals pi on 3, our gradient is equal to b, which means that b is equal to cos of pi on 3 over 2. Right, I've just subbed in pi on 3 for x, because that's the point that our tangent is at. So b is equal to cos of pi on 6, which means that b is equal to root 3 on 2. If you're not too sure about how I got root 3 on 2 here, guys, you've got to review your unit circle. Go to any of the Fortify questions between 100 and 150, and you'll be able to find a video there that helps you to do that. So we've just found b. That's our first mark, right? So we're trying to find 3 different values, a, b, and c. So for each one, we get a mark, roughly. So then, for our c value, we actually know that the tangent passes through this point here. We know that the x value is pi on 3. We know that b is equal to root 3 on 2, which means we can actually sub these values back into the tangent equation to find our y value, which is our c value, right? So y is equal to bx. So b is root 3 on 2. X is pi on 3. Plus 4 minus pi over 2 root 3. Right? So from here, we get pi root 3, or root 3 pi. Pi root 3 is a bit weird, isn't it? Root 3 pi over 6 plus 4. Now, I don't like having this root on the bottom here, so I'm actually going to rationalize that denominator by multiplying this by root 3 over root 3. So then I get take away root 3 pi over 2 times root 3 times root 3, so 2 times just 3, which is 6. As you can kind of pick up and see, this and this are the same, and we're minusing that, so these two actually cancel, and we get y equals 4. That means that our c value is 4, right? Because we've just found the y value of this coordinate, and that happens to be our c value. So our c value is 4, and that's our second mark. From here, guys, we need to find our a value. So we know that the original function, y equals 2 sine of x on 2 plus a, passes through this point, and we now know what that point is, right? So we know that y is equal to 2 sine of x on 2 plus a. Our y value is equal to 4. Our x value is equal to pi on 3 plus a, right? So a is our only constant now, so we're going to be able to solve this. 2 sine of pi on 6 plus a 4. From here, sine of pi on 6 is equal to 1/2 plus a 4. 2 times a half is 1, which means that 4 is equal to 1 plus a, so a equals 3. That's our third mark, guys. So always, whenever you get questions like this, always use the gradient function to find the first constant, right? Because the reason why you want to do that is because when you derive or differentiate the original function, it actually cancels out this constant, so that you're not using another constant in here. You can just sub straight in your x value. So guys, if you have any questions about this, please hit me up in the comments below. But if not, thank you so much for watching and have an awesome night.